I'd want to label it, but I wanted to finish reading the problem before I figure out what variable to call that. What are we looking for first, I guess? Well, question, Emma? What's up?
I just can't tell. Is that an E or is it? Like the marking code for the angle?
Oh, that's a theta.
Theta? Okay.
A theta. You can call it whatever you want. Usually we use thetas for angles.
Okay, thank you.
So what is it asking me to find? At what rate is the angle changing? So what's it asking me for? Find what rate is the d theta dt. So that means I'll need an equation with theta in it. With the theta in it, so that when I take a derivative, d theta dt will show up. And the top of the ladder is 5 feet from the ground. Last one we used A and B and C, so we could probably do that again. So A and B and C. We got to be careful. C is constant because the ladder isn't changing, but A and B are changing. So dB dt is negative 0.5. Okay, they did not give me an equation, so I have to find some equation that has theta in it. Geometry experts. What's an equation we could write that would have theta in it? Okay, so we have options. Sine, cosine, or tangent, or secant, cosecant, or cotangent, but we don't want to use those. Let's see. Let's think about which sides we would like to use. We have dB dt, so we almost certainly want to use the opposite side. And then I need to use either the adjacent side or the hypotenuse. Do you know which one is going to be easier for this problem? One of them is a whole lot easier than the other one. Opposite and adjacent make tangent. That's true. So our options are tangent of theta is b over a. Or, if I wanted to use opposite and hypotenuse, what would that be? Which one is opposite and hypotenuse? Sine. Okay, do you know yet which one of these would be a better choice? Either will work. One's a whole lot better than the other. Why sine? Yeah, since c is a constant, this is going to be way easier. For tangent, both of those are changing. B and A are both changing. So that would require the quotient rule. And then dA dt would show up, but I don't even have dA dt. So I think you could work it that way, but that would be a pain. So instead, let's go sine of theta equals b over, and in fact, I'm not even going to put c, I'm going to put b over 13. Because the 13 is fixed. The danger here is that someone's going to put sine of theta equals 5 over 13. And that's true, but only at one instant, when b is 5. But b is changing, so I need to have that b in there. All right, sine of theta equals opposite over hypotenuse, b over 13. Now I need to take a derivative of each side to make d theta dt show up. Now I can pick on people, because we all know, Claire, what's the derivative of sine? Cosine. So finish this off. That's part of the answer. What's the derivative of sine with respect to t? So cosine of theta. And then chain rule. Somebody help her out. Times what? D theta dt. Does that make sense? Yeah. Times d theta dt. So chain rule, chain rule, chain rule, chain rule every single time. So you got to know the basic rules, but then don't forget to include the chain rule. On the other side, 1/13 is done. But the derivative of b with respect to t, oh, that's just db dt. Okay, and we're trying to find d theta dt. We know db dt. We've got 1/13 cosine of the angle. Cosine of the angle is adjacent over hypotenuse. Do we know what the adjacent side is? It's the same special right triangle or Pythagorean triple we used on Friday. 12. So cosine of the angle is adjacent over hypotenuse. So 12/13. D theta dt equals 1/13 times negative 0.5. Yes, sir?
Why'd you replace the d with the 1?
I put the b out front, and then b is, no, I didn't put the b out front. I put the 1/13 out front. And the derivative of b would just be 1, but chain rule, db dt. Braden, does that make sense now? Okay. Okay, let's multiply by 13/12 to make the 12/13 go away. So d theta dt equals, well, this is a safe stop. It looks ugly, but you could just leave that. It'd be fine, Marie. The dB dt is 0.5. That one? Or, oh, how do I know that b equals 5? Because it said when the top of the ladder is 5 feet from the ground, that means b is 5. This is a safe stop, so I could leave it. The 13s cancel. Negative 0.5 times 1/12. That's an ugly answer because it's got decimals and fractions, but who cares? Like, safe stop. It does say indicate units of measure. We did not keep up with units, but we don't have to. What is the angle measured in? Oh, I'm glad you said that, because it's not right. It's always radians in here. Always, always, always radians. So radians per whatever unit of time we're using per second. Man, that was a yucky one. Oh, I like to make sense of the signs here. D theta dt is negative. Does that make sense for what's happening in this problem? Why? Yeah, so as the ladder slides down the wall, that angle is getting smaller and smaller. So it makes sense that my change is negative. Okay, last one. A 6-foot tall man walks at a rate of 5 feet per second toward a 16-foot tall light pole. Oh, I see a picture in our future here. So, 16-foot tall light pole. When the man is 10 feet from the base of the pole, at what rate is the length of his shadow changing? Oh, lovely. I'm going to try to draw this roughly to scale. So if that's 16, then maybe that's 10. And 6 is maybe that. So here's my man walking along. And the light is this. And I'm going to call his shadow S. He's 6 feet tall. Light pole is 16 feet tall. He's walking toward the light pole at 5 feet per second. He's 10 feet away from the pole. At what rate is his shadow changing? Okay, so I need some formula with S in it so that ds dt will show up. Like, that's what I'm looking for. Find ds dt. Geometry All-Stars. That's you guys. I think I see similar triangles. Okay, I made a small mistake in setting this up because if stuff is constant, then you can label it with a number. If stuff is changing, you need to be careful. So, which of these numbers is changing, and so I better be careful about labeling it.
10.
That 10 is not always 10. He's always 6 feet tall. The light's always 16. So I'm going to say that's L. Because L is changing. What about this 5 feet per second? What is that in terms of L and S and 5 and 6 and 16?
dl over dt.
That's how L is changing because he's getting closer. And I think I need to be careful because the L is getting smaller, so it's actually a negative 5 feet per second. So I need an equation with L and S in it. Barrett?
6s over 2 equals 16l plus s over 2. Or just 16l plus s equals 6ls, or 6s.
I like where you're headed. I don't know if I heard that all correctly, but I definitely need to do some ratios. So I'm going to say, and it doesn't matter, like ratios, it feels like there's 4 or 5 different ways to write it that are all correct. So say what you said again, Barrett. Whatever you saw, I'll go with that.
I said it wrong, but I know what I was.
Okay.
Answer would be 16, or 6 over 16.
Okay, that's a good place to start. So you're going to do this side to this side. So we'll go 6 over 16. So orange triangle to yellow triangle. That means my next statement needs to be orange triangle to yellow triangle. So I like 6 to 16. What's the next ratio going to be? S over L plus S. Yeah. So this is one where they don't give you a formula. You have to come up with the formula. I could take a derivative now, but I'd have to use the quotient rule. So I say we cross multiply and make our life a little easier. So I'm going to say 6L plus 6S equals 16S. In fact, let's keep going while we're doing algebra here. 6L equals 10S. You want to go one more algebra step? Right? Why not make it as easy as we can in algebra world? 3L equals 5S. Okay, I want ds dt to show up, so I need to take the derivative of both sides. Let's pick on some people here. Will, what do you think for the left side? What's the derivative of 3L?
3.
Good. 3dl dt. Isabel, the right-hand side.
5 ds.
Good. 5 ds dt. And then, do I have everything I need? I want to find ds dt. I know dl dt. So 3 times negative 5 equals 5 times ds dt. Is that a safe stop? You got to get ds dt by itself. So, I mean, you're almost there, but it's not safe yet. You need to divide by 5. So ds dt equals 3 times negative 5 over 5. That's a safe stop, but may as well go negative 3 on that. Okay, it didn't specifically ask for units, but let's do it anyway. What are the units of s? Feet, and the units of time? Negative 3 feet per second. It's hard to know if that's a legitimate answer, like 3 versus 5. I don't know. But the negative, does the negative make sense? Should mean his shadow is getting shorter. If he's over here, still the same height. Yeah, that makes sense. His shadow is going to get shorter. Yeah, because when he's standing right next to the light pole, his shadow will be 0. So I've convinced myself that the negative is correct. And if we went the other way, like if he was way out here, his shadow would be really long. So your assignment tonight is to go walk toward the street light on your street and take some measurements. See if this works. Okay, well you see why we saved those two, because we had to come up with our own equations on those. They didn't give us an equation. We had to see what was happening and write an equation. Back to the worksheet. Again, today's assignment is 6 through 17. So let's see what we got here. See, those are nearly 6 and 7 are nearly the same thing we just did with different numbers. How about you try number 8? It's the shadow problem, but they give us different information and ask us for a different thing. So let's try number 8. There's a bit of a setup hint. Shadows and angles. Let's see. We got time for a couple more, or one more anyway. Oh, we need to do a cube or a sphere. Which one do you want to do? 9 or 10? 10? 10 it is. A spherical balloon is being inflated at a rate of 12 cubic inches per second. So even before I go any further, Cody, what did it just tell me? What exactly is 12 inches cubed per second? It's a rate, so I know it's a derivative. So it's d something. So look at the units. What is inches cubed a unit of? Volume. And what is seconds a unit of? Time. So what it gave me was dV dt. 12 cubic inches per second. How fast in inches per second is the radius changing? So, Tristan, what is it asking me to find? Good. Find dr dt. When r equals 2. And they were nice enough to give me the formula this time. So I need to take the derivative with respect to time of that volume formula. That will make all my dTs show up. Evan, how about the left-hand side? But I want to take the derivative of it with respect to t. Alec is whispering it, and whispering correctly. dv dt? Or 1 dv dt? Maddie, how about the other side?
4/3 pi 3r squared dr.
Yes. 4/3 pi, that's the constant. And then 3r squared, but then the derivative of r is dr dt. And yes, the 3's would cancel if we want to clean things up a little bit. dv dt equals 4 pi r squared dr dt. Oh, we're close, right? Because we have dv dt, we have r, and we're looking for dr dt. So 12 equals 4 pi r squared dr dt. So 12 over 16 pi, that reduces, but 12 over 16 is 3/4. So 3 over 4 pi. Let's back up and do the cube. We got time to do the cube on number 9. The cube of ice is melting in such a way that it maintains its cubic shape. If each edge of the cube, that sounds like S, is decreasing at a rate of 2 millimeters per minute, at what rate is the volume changing? Okay, so let's first make sure we understand what we've been given and what they're asking for. Caden, what is that 2 millimeters per minute? D what dt? I called it S because I'm going to say that the S is the side length of the cube. So ds dt. And there's one more thing about that 2 that I didn't put in there that I probably should have. It's decreasing, so that needs to be a negative 2. And Harper, what's it asking me to find? When v is 27. So find dv dt when v is 27. Well, they did not give me an equation for this one, but I bet Audrey knows the volume of a cube.
Is it from the equation 4? Wait, what did you ask me?
The volume of a cube. I need an equation to take a derivative of so that my dv dt will show up. So what's the volume of a cube? What's that? Don't know? It's a bit of a trying to give you a hint there with those 3 dimensions on there. Barrett? S times S times S. Length times width times height. Hector, if I want to find some derivatives, what should I do to both sides? Find the derivative. So let's take a derivative of both sides. Sophia, how about the left-hand side? What's the derivative with respect to t of v? Right, that's the one that's supposed to be the easier one, but sometimes it's almost too simple, it trips people up. Leah, how about the right-hand side? The derivative of s cubed. Yep, 3s squared ds dt. Okay, I think we're good. Find dv dt. We know what s is. Oh, we don't know what s is. We know what ds dt is, but we don't know what s is. Oh, well, they didn't give it to us. But if the volume is 27, then s is 3. So 3 times 9 is 27, times 2 is 54. Negative 54. Units of volume are meters cubed, or I guess we're in millimeters, so millimeters cubed per second. It's negative. Does it bother you that it's negative, or is it supposed to be negative? It's supposed to be negative. It's melting, so the volume is getting smaller, so it makes sense that the V is shrinking. All right, so try some of those.